So with redox, we're talking about oxidation and reduction. So some of the things that we can do to remember is oil rig. Oxidation is loss. Reduction is gain. And that's of electrons. But some things that we can look at with this can be a little counterintuitive. So if we're losing electrons, the oxidation number should go up. So loss is going up, and if we're reducing, we're gaining electrons, so the number is going to go down. So we're talking about gaining and losing negative charge, which is often counterintuitive to people. So not only are we going to have a substance that is oxidized and one that's reduced, but we're also going to have a reducing agent and an oxidizing agent. So I highly recommend paying attention to this part and writing some notes down. The agent is going to be the opposite of what you think it is. So it's going to be the reducing agent because it's allowing the reduction to take place by being oxidized. And the oxidizing agent is allowing the oxidation to take place by being reduced. So it's a little counterintuitive to what we think. So here we go. So these have the oxidation numbers written in for you, probably because my animations are messed up. But iron here is 0, iron here is +3. Oxygen here is 0 because it's in its gaseous state. And then here it's -2. So what happened was iron went from 0 to iron +3. So it had the oxidation number increase. So that was oxidized. And here oxygen went from 0 to -2, so it was reduced. Gain electrons, it goes down. So the reducing agent, let's say what was oxidized, let's start with that, would have been the element itself. So we talk about elements, would be iron. What was reduced would be oxygen. What was the oxidizing agent? So the oxidizing agent contains the element that was reduced. So we look for what was on this side. It's always going to be one of the reactants. So if the oxidizing agent is going to contain the element that was reduced, it means it has to contain oxygen. So in this case, it's O2. And honestly, the answer to this one should be O and not O2, because we're talking about an element, not a compound. And then the reducing agent contains the element that was oxidized, so it would be iron. In this case, they're both elements. That's not usually the case. So this is a 3. Seems like my animations are a little messed up today. So looking at the oxidation numbers here, carbon is in its neutral state. It's going to be, so this is solid carbon, so it's going to be a 0. Here, carbon went to +4. Iron here was +3, and it went down to -2. So +3 to -2, that was a reduction. And then from 0 to +4 was an oxidation. So what was oxidized? What was reduced? What was the oxidizing agent? And what was the reducing agent? So oxidized was carbon. Reduced was iron. So in this case, even though it's Fe2O3, we're only going to write iron because iron was the element that was reduced. Oxygen did not change here. Oxygen is -2 on the left and -2 on the right, so it doesn't change. The oxidizing agent contains the element reduced, so we look for the element that was reduced was iron, and this is where we actually write the entire compound, so Fe2O3. So when we're talking about what is oxidized and what is reduced, these should be elements, and these might be elements or compounds, depending. So what was the reducing agent then? The reducing agent contains the element that was oxidized, so in this case it's actually just going to be carbon. So oxidation reduction reactions are single replacement reactions. We are replacing one element with another. They don't always go forward. If this were the case, we have to look at a chart and a chart will tell you it's called an activity series. Not something you will have to memorize. If it's something you need, you'll be given the activity series. If something is higher on the activity series, it will replace it. So if we want to know if zinc will replace copper in this reaction, which it will, the zinc would have to be higher on the activity series than copper, which it is. I don't have one to show you right now, but that's what you'll look for. So if you need that information, you'll be given that information. It's not something you'll have to memorize. The first thing we need to do is assign oxidation numbers. So zinc here is 0, and copper here is 0 because they're both in their elemental state. We know here that chlorine is -1. -1 times 2 is -2. That has to equal 0, so this must be +2. And then here, -1, zinc is +2. Again, you could know that zinc is always +2, or you can figure it out because this is -2. We want it to equal 0. So once you get your oxidation numbers written in there, we can figure out what is oxidized, what is reduced, what is the oxidizing agent, and what is the reducing agent. So oxidized, let's look at what changed. So chlorine didn't change at all, but zinc went from 0 to zinc +2. So the oxidation number increased. So look here, copper went from 2+ to copper 0. So this was increased, that means it's oxidized. Oxidation number decreased here, so that means it's reduced. So oxidized would be zinc, reduced would be copper. The oxidizing agent contains the element reduced. So if the oxidizing agent contains the element reduced, we're looking for what contains copper. That would be copper 2 chloride. And the reducing agent contains the element that was oxidized, so that would be zinc. I can erase this so you can see it, not with my handwriting if you'd like. So this is where we're talking about looking at an activity series. So an activity series, which of these two reactions would occur? So we have solid copper, and then we have a silver ion. So some type of silver in solution is going to copper in solution plus silver solid. So silver would be deposited, or would the silver solid replace the copper to form silver ion and copper? So we need to look at an activity series and see which one is higher on the activity series. So this is the activity series. We're looking for copper and we're looking for silver. So here is silver and here is copper. They're directly on top of one another. So copper, being higher, would replace silver, but it would not happen the other way around. So copper will replace silver. So this reaction would occur, this one would not. And that's what we see here. So this is solid copper wire, and we put it into a solution of, well, in this case, the silver ions. So let's see, let's go back. So we're going to see the copper is going to deposit. The copper is going to go into solution, and the silver is going to deposit onto here. So this is actually solid silver that's depositing on there. And I'm sorry I won't get to show you guys that. I'd like to show you that in the lab, but oh well, you'll get over it. So this is what's happening. The copper wire gets reduced. It goes into solution. That's why the solution's turning blue, because copper 2 ions are blue. And the silver is actually getting deposited on top of the copper. All right, so this is where you need to pause it and you need to try it. So go on, try assigning the oxidation numbers. Tell me what's oxidized, what's reduced, what's the oxidizing agent, and what's the reducing agent. All right, so pause it. Do it for real. Okay. -2 times 4 is -8. +1 times 2 is +2. So what +2 plus -8 equals 0 would be +6. All right, so this one's a little tricky, but you know SO4 is 2-, so you can break that off. And then here, this actually tells you aluminum is 3+, so we know that one's going to be +3. So you can take out SO4, and you know it's going to be 2-. -2 times 4 is -8. So what plus -8 equals -2? That's +6. So you can do that way. You can also multiply through by all the coefficients, but you're just going to end up working with really high numbers and it becomes more difficult. So aluminum went from aluminum 0 to aluminum 3+, and hydrogen went from +1 to hydrogen 0. This brings up a point that I should probably mention, or I like to mention. The most simple definition for oxidation reduction is oxidation is the gain of oxygen or the loss of hydrogen, and reduction would be the opposite of that, would be the loss of oxygen or the gain of hydrogen. So actually, when you go to organic chemistry, those are the only two things you really need to remember. That'll usually save you a lot of headache. You don't need to assign oxidation numbers all the time. So if aluminum went from aluminum to +3, the oxidation number increased. So oil rig, we look at that. This would be an oxidation. Here the oxidation number decreased. So this would be a reduction. So aluminum was oxidized, hydrogen was reduced. The oxidizing agent contains the element reduced, so we look back here, H2SO4. The reducing agent contains the element oxidized, so that would be aluminum. Definitely some things you're going to want to practice and do because especially the agents are counterintuitive. Try another one. Pause it. So -2 times 2 is -4, so this must be +4 in order for it to equal 0. Good, got that far. Got your oxidation numbers. Hopefully at least you got that part down by now. What changed? Lead went from +2 to lead 0, and carbon went from +2 to carbon +4. So here we had a decrease in the oxidation number, and here we had an increase in the oxidation number. Now if we look at this at a top level, carbon gained oxygen, so it was obviously oxidized. So this is oxidized and this is reduced. So oxidized would be carbon, reduced would be lead. Oxidizing agent contains the element that was reduced, so we're looking for the one that contains lead, PbO. Reducing agent contains the element that was oxidized, so whatever is with carbon on the reactant side. Remember, all of your answers come from the reactant side. Good. One more. 0 plus 1 minus 1 plus 2 minus 1, 0. Magnesium went from 0 to magnesium +2, and hydrogen went from +1 to hydrogen 0. Oxidation number decreased, that's a reduction. Oxidation number increased, that's an oxidation. So element being oxidized would be magnesium, reduced would be hydrogen. Oxidizing agent contains element reduced, and the reducing agent contains the element oxidized. I know, isn't this a joy? All right, so we're looking for the one that contains hydrogen here, so that would be HCl. And the reducing agent would contain magnesium, which is just magnesium in this case. Let's balance them. So that's enough for the figuring out what the oxidation numbers do and how we can tell what was oxidized and what was reduced. We can use that information to write oxidation half reactions if we'd like. To do that this way, we're going to learn to balance these. These are way different in balancing than anything we've done before. they are a 6 to 8 step process. So let's get started. Let's try a couple. Just get into it. Here's your steps. You guys can take a picture of it, read them, copy them down, whatever you need to do. But we are going to follow those steps as we go throughout. And if we follow all the steps properly, we should be fine. Everything should come out. And if it doesn't, well, then we keep trying. All right, so let's start by this one. This is the unbalanced half reaction. Here we go. Now, honestly, it doesn't really matter if we know which one's the oxidizing half reaction, the reducing half reaction. We're going to balance them the same. But the first thing that we're going to do is write the unbalanced half reactions, net ionic equation, excuse me. So this is step 1. Step 2, determine which is oxidized and which is reduced. We can see that this one lost oxygen. So if it lost oxygen, it's obviously being reduced. So we can see that. Also, if we look at the oxidation number of iron, it increased here, so that means it's oxidized. So if we wanted to, we could label those, but you really won't have to be able to label them. You just have to be able to balance them. So the oxidation half reaction would be Fe2 plus goes to Fe3 plus, and the reduction half reaction is going to be Cr2O7 2 minus. Make sure you write these correctly. If you get a typo here, it really kind of sucks. All right, so this is step 1. Step 2. Now step 3 is balance everything except for oxygen and hydrogen. So we have 1 iron on the left, 1 iron on the right. That's balanced. Here we have 2 chromium on the left. We need 2 chromium on the right, so put a 2 there. Now everything is balanced except oxygen and hydrogen. Step 4 is to balance every half reaction for oxygen by adding water to the side that's deficient in oxygen. There's no oxygen in this half reaction with iron, so we're going to start here. We need 7 oxygens, so we're going to have 7 H2O to this side. That's oxygen deficient. So now we have 7 oxygens on the right and 7 on the left. Then we're going to balance for hydrogen by adding H plus to the side. That's hydrogen deficient. Well, there's no hydrogen in the iron half reaction, so we look over here at the right. And there are 7 times 2 is 14 hydrogens on the right. So we need 14 H plus on the left. So now we are on step 5. Balance each half reaction for charge by adding electrons to the side with the greater positive charge. So let's look at charges. Charges can be difficult. So over here we have +2, over here we have +3. In order to make charges, we have to go down. So go to the side with the higher charge and we add to that side. So this will be +1. Now here we have 14 plus -2. So this is 14 plus -2 is +12. Over here we have 2 times 3 plus is +6. So these do not need to equal 0, they just need to equal each other. So on this side we're going to add 6 electrons. So then we need to multiply the equations until we get the same number of electrons. So this one needs to be multiplied by 6 to get to 6 electrons being transferred. 6 Fe2 plus goes to 6 Fe3 plus 6 electrons. And then over here we already have the 6 electrons. Step number 6, we're going to add the 2 equations together. So 6 Fe2 plus 6 Fe3 plus 6 electrons. On this side we have 6 electrons plus 14 H plus Cr2O7 2 minus goes to 2 Cr3 plus 7 H2O. Now your electrons should always cancel. If they don't cancel, then you did something wrong. Because remember we have to transfer the same number of electrons simultaneously. So then we add this up. We get 6 Fe2 plus 14 H plus Cr2O7 2 minus goes to 6 Fe3 plus 2 Cr3 plus 7 H2O. And that would be our final. Okay, I'm going to remove this and click through it so you can see it as I added it to the PowerPoint as well. So some reactions occur in basic solution. You'll notice in that last one we had hydrogen ions floating around. If it happened in basic solution, we wouldn't have hydrogen ions floating around. So if it happens in basic solution, we have to do 2 more steps. For each hydrogen ion, we need to add 1 OH to both sides. And then anytime you have H and H plus and OH on the same side, you'll combine them to make water. So this one says balance it in basic solution. So we're going to do that. So Cn minus goes to CnO. And here we have MnO4 minus, don't forget the minuses, MnO2. So first step, write the half reactions, or well, first step is write the equation that was given. Then we write the half reactions, balance for everything except hydrogen and oxygen. 1 carbon and 1 nitrogen on the left, 1 carbon and 1 nitrogen on the right, 1 manganese on the left, 1 manganese on the right. So we're good there. Then we need to balance for oxygen by adding water to the side that is oxygen deficient. So here we're going to add an H2O, and here we have 4 oxygen, here we have 2, so we need to add 2 H2O. We have 2 hydrogens on the left, we need to put 2 hydrogens on the right here, and here we have 4 hydrogens on the right, we need 4 on the left. So now we're going to look at charge. Here we have -1, and here we have +2 minus 1 is +1. So we're going to add 2 electrons because +1 minus 2 gives us -1. Here we have 4 plus and -1 for an overall of +3, and here we have 0. So we're going to add 3 electrons to this side. So I'm going to rewrite that. And here we have 3 electrons plus 4H plus MnO4 minus MnO2 plus 2H2O. All right, one of them has 3 electrons transferred and the other one has 2. So we're going to multiply this one by 3 and this one by 2. And we get 3H2O plus 3Cn minus goes to 3CnO minus plus 6H plus 6 electrons. And over here we have 6 electrons plus 8 plus, okay, I can talk, plus 2 MnO4 minus goes to 2 MnO2 plus 4 H2O. We're going to add those together. And when we add those together, we're going to have 3 H2O plus 3 Cn minus 3 CnO plus 6 H plus 6 electrons. Over here, 6 electrons plus 8 H plus 2 MnO4 minus is 2 MnO2 plus 4 H2O. Our electrons should cancel, and they do. What else can cancel? I have 6 H plus 8 minus 6 would leave me with 2. I have 3 water, so that'll leave me with 1 water. And that will give me 2H plus 3Cn minus plus 2MnO4 minus 3CnO, 2MnO2 plus H2O. And that should be our final. But it's not, is it? That's our final if we were in acidic solution. But we're not, we're in basic solution. So since we're in basic solution, we need to go to the side that has, if there's any H plus left around, we have 2 over here, so we need to add 2 OH minus to both sides. So here, that's going to make 2 H2O. And so plus 3 Cn minus goes to 3 CnO minus plus 2 MnO2. I have a water here that's going to subtract and make that 1 water because they're on different sides, so that one crosses out. And I'm going to be left with plus 2 OH minus. So that is our final answer. So we're going to balance this one. So we're going to balance it in acidic solution. So we're going to start with the half reactions. And here we have Cr2O7 minus goes to Cr3 plus. First thing we do is balance for everything except hydrogen and oxygen. So 1 iodine on the left, 1 iodine on the right, we're good. We have 2 chromium on the left, we need 2 chromium on the right. And now we're balanced for that. Balance for oxygen by adding water to the side that is oxygen deficient. I'm just going to make that a little smaller. So we need to add 3 oxygens, so we add 3 water. And that's good for oxygen. Then we are going to balance for hydrogen by adding H plus to the side that's hydrogen deficient. So we have 6 hydrogen over here. We're going to add 6 H plus to this side. Over here we have 7 oxygen. We need 7 on this side, so plus 7 H2O. And now we have 14 hydrogen on the right, so we need plus 14 H plus. So that's that for that step. We're going to now balance for charge. So I'm going to switch here to color. We have -1 on this side, and we have -1 and 6 plus, so that becomes +5. So if we want to get from +5 to -1, we must add 6 electrons to this side. Over here we have 14 H plus -2, so we have +12. And here we have 2 times 3 is +6. So we need 6 electrons on this side, so we're going to add 6 electrons to this side. So we can actually add these straight together because we both have 6 electrons. So we're going to say, I'm just going to put on one of these sides because there's a line down the middle. So 3H2O plus I minus goes to iO3 minus plus 6H plus 6 electrons. Now my other half reaction, we say 6 electrons plus 14 H plus Cr2O7, 2 minus, goes to 2 Cr3 plus 7 H2O. Bring in and cancel anything we can. So right now we have 3 water over here. It would bring us to 4 water on this side. The electrons cancel. 6 H plus and 14 H plus. So that would be 8 H plus that's left. And now we add together. So I minus plus 8 H plus Cr2O7 2 minus to IO3 minus plus 2Cr3 plus 4H2O. And that's our final answer because we're allowed to keep the hydrogens because we're in acidic solution. So since we're in acidic solution, we're done. Next up, make sure you pause it and try this one. We're going to do the same thing, but in basic solution. So basic solution means we have 2 extra steps. So we're going to get to the half reactions. MnO4 minus goes to MnO2. And Br minus goes to BrO3 minus. Balance for everything except hydrogen and oxygen. 1 manganese on both sides, we're good. 1 bromine on both sides, we're good. Now we balance for oxygen by adding water to the oxygen deficient side. So I need 2 more oxygen over here. Now I balance for hydrogen by adding H plus to the hydrogen deficient side. So I need 3 water over here. And now I have 6 hydrogens, so I'm going to add those on this side. So now we balance for charge. 4H plus and 1 minus gives us 3 plus. Over here we have 0. So I need to add 3 electrons to this side. So 3 electrons plus 4H plus MnO4 minus goes to MnO2 plus 2H2O. Remember, they don't have to equal 0, they just have to equal each other in the charge. So this is minus 1, and this is minus 1 plus 6 is plus 5. So I need to add 6 electrons to this side. So I have 3H2O plus Br minus yields BrO3 minus plus 6H plus 6 electrons. So now we add them together, or what do we have to do first? Nope, we have to do something else first. I have 6 electrons here and 3 electrons here, so I need to multiply this whole equation by 2. So 6 electrons plus 8H plus 2 MnO4 minus goes to 2 MnO2 plus 4H2O. And we're going to add that to this one, so we say 3H2O plus Br minus goes to BrO3 minus plus 6H plus 6 electrons. Now we can cross off anything that's the same on both sides. 6 electrons, 6 electrons. I have 3 water. That'll leave me with 1 water. 6H plus. This will bring me down to 2H plus. And then we go 2H plus 2 MnO4 minus plus Br minus yields 2 MnO2 plus BrO3 minus plus H2O. But this is basic solution, so we're not done yet. So we need to find any H pluses. There are 2 of them, so I need to add 2 OH minus to both sides. When I do that, this is going to form 2 water. So I'll have 2H2O plus 2 MnO4 minus plus Br minus. It's 2 MnO2 plus BrO3 minus plus H2O plus 2OH minus. The water here cancels one of the waters here, and now we have our final answer of H2O plus 2MnO4 minus plus Br minus yields 2MnO2 plus BrO3 minus plus 2OH minus. So that is our final answer. Good. And these are just some of the ways that we use redox reactions. So that's it for chapter 7 and 14.